I am Anil Kumar Khandelwal. Welcome to my book on calculus, from where we are taking some challenge questions. Here is a very beautiful question for you. It is on optimization. If f be a function such that f of minus 1 equals to 1, if dy dx is equal to minus x squared minus xy plus y squared minus 1, which of the following statement is true? F has relative minimum at x equals to minus 1. F has relative maximum at x equals to minus 1. F has neither a relative minimum nor a relative maximum at x equals to minus 1. And D is there is insufficient information to decide about the relative optimum value. Pause the video, answer the question, and then look into my suggestions. So let's see what is given to us and how we can solve this problem. So one is we are given that f of minus 1 equals to 1. That means at x equals to minus 1, y is 1, right? So if x equals to minus 1, in that case y equals to 1. That is what it means. Or you can say that the point on the curve, which is minus 1, 1, right? So these are different representations of this given information. The other information given to us is the derivative of this particular function. So we are saying that dy dx is equal to minus x squared minus xy plus y squared minus 1. Now, if the derivative is given to us, then maximum or minimum will occur only if derivative is 0 at x equals to minus 1 in this case, right? So what we can do is we can find what is this value at x equals to minus 1. Is that clear to you? So that will be minus 1 square minus of minus 1. Y is 1, correct? Plus 1 square minus 1. So minus 1 square is 1. So minus 1, and this is, let's write down. So minus 1, so this is plus 1, correct? And this is again plus 1, and this minus 1. Definitely, this is equal to 0. Since the derivative is 0, we could have either a maximum or a minimum at this particular point. But we need to test it. How do we test it? Now, clearly, we cannot make an interval table in this case. Question is kind of complicated. So the other option for us is to find the second derivative. Once you find the second derivative, then you know whether it is maximum or minimum. So there is enough information for us to get the right result. Is that part clear to you, right? Okay, so now let's figure this out on a fresh page. So we are given the derivative, which is dy dx equals to minus x square minus xy plus y square minus 1. So second derivative will be what? So the second derivative will be minus 2x. Now product rule. So this is minus y minus of x times dy dx, right? So y square derivative will be 2y dy dx. And minus 1 derivative will be 0. Now what else you know about it? So at x equals to minus 1, we know y equals to 1. Also, what we know is dy dx at x equals to minus 1 is equal to 0. So those are two critical informations known to us. So let's evaluate all this at, let me write like this, d2y dx square at x equals to minus 1. So it will be minus 2 times minus 1. Y value is plus 1. X is minus 1. Dy dx is 0. Plus 2 times 1 times 0, right? Okay. So the last two terms are 0. The first two are minus and minus is plus 2. And then we have minus 1, so which is plus 1. So we see that this is second derivative of the function. Let me write like this. Is positive, right? Since it is positive, we now know that the graph should be opening upwards with a minimum value. Is that clear? So we can conclude that at f of minus 1, we have local minimum. Is that clear? And so the option for us is option A. F has a relative minimum at x equals to minus 1. Makes clear? So that was a very difficult question solved step by step. I hope you understand and appreciate it. You can always contact me to learn more. Thank you for your valuable time and all the best.